So let's leave Fukushima and extraordinary conditions for a moment and talk about safety in ordinary operations. So there, as I say, there are four things I'll talk about: background radiation, tritium, spent fuel, and antiproliferation. Let's talk about background radiation levels. Natural background radiation in this area is about 350 millirem per year. You get that just by sort of standing around. At the fence line, Vermont Yankee adds 20 millirems to that. If you lived at the Vermont Yankee fence line, you would get an extra 20 millirems. On the other hand, if you take a cross-country plane trip, you'll get 3 millirems. If you take a dental x-ray, you'll get 3 millirems. There are many, many ways that you can get an extra 15, 20, 40 millirems very quickly. And the easiest way is to move uphill. Denver is not as shielded from cosmic radiation as we are, and it is 1,000 millirems per year. And actually, there have never been any studies that show that between 350 and 1,000 millirems per year makes a bit of difference in terms of cancer, birth defects, anything like that. That basically it's all within the limits that people were sort of designed to deal with. That is, we live on this Earth, and this Earth has background radiation. Here's a map of background radiation showing you how complicated the situation is. Moderate is yellow and low is blue. Now you're looking around saying, wow, it's all confused up here in the Northeast, and that's true. The reason it's confused is background radiation depends on whether you're on granite, more background radiation in granite than on limestone. It depends on how high up you are, if you're living down by the Connecticut River or Muskoma Lake or up in the hills. And so it's really hard to do a nationwide map on it. We quite reasonably don't consider this when we make our housing choices. I don't say, oh, I don't want to live on that hill, you know, there's more background radiation. I think, oh, nice view. Or, oh, I want to live down by the river, it's pretty. As I say, the background radiation varies a great deal, and Vermont Yankee adds trivial amounts to it. So let's go on to this tritium leak. Everybody was very concerned with the tritium leak. The tritium is a hydrogen isotope that emits beta radiation. Beta radiation sounds pretty sneaky, but it is just electrons. Potassium is also a beta emitter. It isn't irradiated by some evil scientist. It just, from the beginning of the Earth, potassium has been emitting beta radiation. So what are the comparisons? Let's say you drank 2 quarts of water at the EPA limit for tritium. So how much beta radiation would you get internally? Well, about a bite of a banana, basically. Or maybe half a cup of milk, which also contains potassium. So how much tritium was emitted? Now, you can buy a tritium illuminated exit sign on Amazon, and it'll be shipped to you through the mail. They don't ship hazardous stuff through the mail. This exit sign will contain 5 to 25 curies of tritium. You understand that a picocurie is a trillionth of a curie. So you can say this contains 5 to 25 trillion picocuries of tritium. The entire Vermont Yankee leak, if you were able to gather up all the water that leaked from it, would be 1/2 to 2 curies of tritium. And it's, so what, is that a lot? I mean, you know, we can ship an exit sign through the mail, but people might say, well, yeah, but that's different, you know. Canadian plants make a lot more tritium than we do, and they routinely release 5,000 curies per plant into the local water. Since the amount of water tritium in the water anybody drinks stays below EPA limits, it has never been any kind of health problem. Vermont Yankee is a zero-release plant. It's a plant that is not supposed to release any tritium. It had a 2 curie total leak. This is compared to 5,000 emitted routinely with no health effects in Canada all the time. So just to remember that a picocurie is a trillionth of a curie, and so this business of 20,000 picocuries is quite something. Another thing is that outside of the plant, outside of the places that they were drilling wells specifically to look for tritium, no tritium above the detection limits has ever appeared. There isn't tritium above the detection limits. You can't find 20,000 picocuries in any water supply.